Hello everyone, welcome in our new video on the chapter electric field. In this video, we are going to learn about the concept of electric field lines. So what are electric lines or what is the meaning of this topic that we are going to study in this lecture? Electric field lines are curved or straight lines, but these are imaginary lines. They do not exist in real. Actually, these are lines which give the pictorial representation of electric field. So we can say that electric field lines are curved or straight imaginary lines in the electric field such that the tangent at any point on the field line gives the direction of electric field at that point. So now here are the two images. These images help us to understand the concept of the electric field lines in a very proper way. For the first image, there is a positive charge and this charge be taken as a source charge. And suppose here is the another positive charge, but this charge is a test charge. For the source charge, there is the generation of the electric field around it, and this space is the region in which its electric field or its influence can be experienced. When the test charge is coming in the space around the source charge, then the test charge will experience a repulsive force, and that repulsive force is radially outward. So we can see from the figure there are the large number of the arrows around a source charge. These arrows indicate the intensity of electric field of source charge at the different points. The size of any arrow is proportional to the intensity of electric field at that point, while the direction of the arrow indicates the direction of the force on the unit positive test charge or the direction of the electric field. When we join all these arrows, we can say that all these arrows take a form of the radially outward lines from the source charge, and these lines are known as the field line. So the first figure shows about the electric field for an isolated positive charge. Now we can see the another figure. In this figure, we take the source charge as a minus q charge, and suppose that there is the test charge, that is the plus charge, and this test charge is a unit positive charge. When this charge come in the space around the source charge, it will experience a force and we get the electric field lines radially inward. So for the negative charge, electric field lines are radially inward, and for the positive charge, electric field lines are radially outward. The test charge is always as a unit positive charge. So now we are taking the case of the two equal point charges. Here in this figure, we have the two equal positive point charges, and this figure represents the electric field for the two equal point charges. Similarly, we can take the two equal negative point charges, and this diagram represents the electric field lines for this case. So now we can consider the another topic, that is the neutral point. So what is neutral point? Neutral point is denoted by the symbol N, and neutral point is that point where net electric field intensity is zero. So for the two similar point charges, neutral point lie exactly at the same distance from these two charges, whereas it lie closer to the smaller of the two charges if these charges are unequal. We have seen in the previous slide the two similar kind of the charges, and for those charges their electric field lines at a center point is going far away from each other. But if we are taking the case of the charges that are of the opposite nature like plus q and the minus q, then their electric field lines contract lengthwise to represent the attraction between two unlike charges, and the tangent at any point on the field line. Like for example, if I draw the tangent at this point, then this tangent gives the direction of the electric field intensity at that point. So now how to represent uniform electric field with the help of the electric field lines. You can see it very clearly from the figure that a uniform electric field is represented by straight EQ spaced parallel field lines. So now this figure represents the electric field produced by two equal and opposite charged parallel plates, and the electric field is greater to be uniform, and it started from the positive plate and goes up to the negative plate. Now the next one is a non-uniform electric field. Example for the non-uniform electric field is an isolated charge. So the electric field of isolated charge is non-uniform and it is represented by radial lines, and these lines are not parallel to one another, which represent they having the different strength at the different points and also having the different directions. So dear friends, revise all the diagrams very well. For any query, you can just pause your video, check all the diagrams, and you can clearly understood how to draw the electric field lines for the similar charges and for the unlike charges. So now we are going to sum up about the concept. So here are some properties. First of all, electric field lines are imaginary lines. The electric field lines begin from positive charge and end on negative charge. The field lines never intersect each other. If the field lines intersect each other, then at the point of the intersection, there are the two values of the electric field that is not possible. The tangent at any point on an electric field line give the direction of the electric field at that point, and the electric field lines contract lengthwise to represent attraction between two unlike charges, whereas electric field line exact the sideway pressure on each other to represent the repulsive charge spheres or the repulsive nature of the charges. Here we see the electric field lines which are red in color and the two plates having the area S and S dash. These electric field lines crossing the cross-sectional area represent the density of the field lines, and these represent the magnitude of the electric field. So in the area S dash we see that electric field lines are very closer or crowded, which means that electric field is strong at this point, and the field lines when they are very far away or spread out like it is shown for the plate having the area S, which means that electric field is weaker. So density of the field lines represent the magnitude of electric field. If density is large, then the magnitude of electric field will be greater. If the density is less, then the magnitude of electric field is taken as weaker. So now it is a time for the revision of the concept of electric field lines. Try to answer these questions, pause your video, revise all the content, and you come to know about the answer of these questions. Thank you for watching our video. Hope you liked it. Take care. Have a nice day.